problem. You need to know the properties of a kite. In a kite, the diagonal that connects the congruent sides is going to bisect the other diagonal. Not necessarily the other way around, but we do know that these two pieces, AE and EC, therefore have to be the same. So what we can do is take their expressions right here and set them equal. So if we know that AE is equal to CE, then 16x plus 24 is going to have to equal 4x plus 42. And so in solving this, if we subtract a 4x from both sides, and at the same time, we can subtract a 24 from both sides. Okay, we get 12x is equal to 18. When we isolate our x by dividing both sides by 12, we get x is equal to, and we can reduce this fraction, right? 6 goes into 18 3 times, 6 goes into 12 twice, so we get 3/2 as our value for x. So we can choose either one of these to plug it into. It doesn't matter which one, whichever is easiest for you. So if we take this first one, 4 times 3/2 plus 42. Half of 4 is 2. 2 times 3 is 6. 6 plus 42 gives us 48. So we know that each of these lengths, AE and EC, is going to be 48. All right, so there's the first part. Now, if we label what we have in our problem, we have an angle EBA of 50 degrees. And then we have this whole angle of BAD that's 114. Okay, so there's the angles that you're looking at. Okay, so what you want to do in order to solve this is one of the unique things about a kite is not only does this diagonal connecting the congruent sides bisect the other one, but they intersect at what measure? They intersect at a 90-degree angle, right? So we know that this is going to form a right triangle, ABE. And so if we look at this right triangle, we now have a leg of 48. We have a known angle measure, 50. Can we find the hypotenuse? Yeah. Okay, we have an angle, the opposite leg, and a hypotenuse. What trig ratio relates opposite and hypotenuse? Sine, right? So we can use the sine ratio, and we can make the statement that the sine of 50 degrees is equal to the opposite leg, 48, over the hypotenuse A. If we do the math here, we multiply both sides by A to get it out of the denominator. Then we want to isolate A, so we can do that by dividing both sides by the sine of 50. That isolates our A completely. And so here's our calculated value. If we take 48 and we divide by the sine of 50, I'll put it in decimals so my answer is displayed as a decimal. I get my measure for A to be approximately 62.7. Now remember, this isn't exactly 62.7, it's just an approximation. So when we go back to actually figure out the perimeter, you're going to use this exact value, the value in your calculator. Don't round it off before you finish the problem. So we know that these two sides are equal to each other, so they're both going to be 62.7. Right, now we still have another triangle that we need to solve for, or another measure that we need to solve for. I'll call it B. And we need to find the other leg of this, or the other side of this kite. So if we look at that leg, or that side of the kite, it also happens to be a portion of a right triangle. In this right triangle, we have this leg of 48. We have an unknown hypotenuse. Is there any angle that we can find in there? Yeah, we can find this angle, right? If the whole thing is 114, how much of it is this upper portion, the portion in this purple triangle? Okay, the acute angles of a right triangle are always complementary, so the complement of 50 is 40. So this angle is 40 degrees. If you remove 40 from 114, you're left with 74. So now we have this second right triangle to work with. With respect to this triangle, we have a known angle, a known now adjacent side, and then an unknown hypotenuse. So what trig ratio relates an adjacent side and a hypotenuse? Cosine. Okay, so we can set up our cosine ratio of this measure. 74 degrees is going to equal our adjacent side, which is 48, over our unknown, or the hypotenuse, which is our unknown b, and then do the same type of math. We multiply both sides by b to get it out of the denominator, isolate b by dividing both sides by the cosine of 74, and so we can solve for b here in our calculator. If we take 48, divide by the cosine of 74. Again, I'm putting a decimal there, so my answer is displayed as a decimal, and I get approximately 174.1. Okay, so I know that each of these sides is exactly the same. That's the definition of a kite. And so my final step to calculate the entire perimeter is just to add these up. So if I take this measure right here, and I add it to the other measure that I found up here, okay, and I find that measure, that's half of it, right? Because I have to double it. I just did one side of this kite. So if I multiply this by 2, I get my overall answer, which you guys correctly identified as 473.6. Well done.